right, so now we want to cover this concept of precision versus accuracy, and these are two very important concepts once we get into the lab. So a definition for being precise means being exact as in performance or execution or amount. So in physical science or lab-based sciences, this means having repeatable, reliable results or getting the same measurement each time. So precision usually is a measurement that measures the ability of the researcher to actually conduct the research and to be precise in their measurements. So how well are they actually executing and doing the experiment? Accuracy, on the other hand, is capable of providing a correct reading or a measurement. So in physical science, this means that you get the correct answer. And so accuracy usually is based on the calibration of the machinery that you're actually using. So if you have a miscalibrated piece of equipment, you could be very precise in your measurements, but you'd get the wrong answer every time. So if we're thinking about a bullseye, we can use a bullseye to kind of represent both precision and accuracy. So what would this represent here if we had this bullseye? Well, these measurements would be very precise, so they're in a tight locale, but they're not on the bullseye, so they're not very accurate. If we have this bullseye here, and we have them right dead on center, and we have repeatable measurements, this would be an example where you have both precision and accuracy. And then in this diagram, this is showing that you have no precision and no accuracy. So in this case, if you've got measurements that are not repeatable at all, this is going to indicate that the researcher is probably sloppy. Like maybe if you're taking measurements or you're drying down something, that you spilled some of the sample on one of the runs and maybe on the other one you left too much water in there and didn't evaporate it all the way off. So you're not getting repeatable measurements. It also could be that your equipment is also miscalibrated, but you can't really tell. If you're imprecise, you can have very accurate equipment and still get the wrong answer. So again, this would indicate that you have an accuracy problem, and this is probably an error in the calibration of the equipment. So the equipment needs to be toggled or recalibrated so that you get the correct measurements. So both of these things are very important when it comes to evaluating natural phenomena and trying to make scientific measurements. If you have precise but inaccurate measurements, again, this is going to occur when the equipment that's used for measuring is typically not calibrated correctly. So you get very precise readings, but they're not accurate. They don't give you the real weight of the compound if the balance is not calibrated. Poor precision and accuracy usually occurs from the scientist, again, having a lot of errors within their measurements. So rushed or careless scientific research will result in imprecise measurements. So this is very bad science. So this should not happen. You should at least get repeatable measurements when you're working within the lab. So this one has no precision and no accuracy. So what we strive for in science is to be both precise and make accurate measurements. So be careful when you're conducting your experiments to make sure that you have good precision and that you can make repeatable data within the lab. So researchers generally test their results for precision by repeating experiments at least a total of 3 times or more. And then results should also be able to be repeated by other research groups in distant locations. And so that's the real test to see whether an experiment is going to be validated and upheld within the scientific literature. If we think about the case of new medicines, they're only approved for use after they've been tested hundreds to thousands of times for their efficacy and safety within the human population. So this is an example where you have a huge amount of repeat data before you can validate the activity of these different compounds. And even then, sometimes we don't catch some of the safety issues with different medicines.